So yesterday, or on the previous lesson, with descriptive statistics, we were using interquartile ranges to describe the spread in a set of data. Now today we're going to look at mean absolute deviation. So we're looking at the mean absolute deviation of a set of data is the average distance each data point is from the mean. So we're looking at how far away is each value that we have, how far away is it from the mean? How different is it from the mean? Are all of the numbers pretty close to the mean, or are they pretty far from the mean? What is the average distance from the mean? In order to figure that out, we have to follow a few steps. So our very first step in finding mean absolute deviation is to find the mean. We discussed previously that to find the mean, you add all of your values, divide by the number of values. Once we have calculated our mean, the next thing we're going to do is we're going to find the distance from the mean. So if we're finding the distance each value is away from the mean, we're going to subtract. And just an FYI, distance is always positive. There are no negative distances. So this is kind of like they put it in the word absolute because it's absolute value. We're just talking about how far away is it. There are no negatives. Third, you're going to average the distances. Also known as finding the mean of the distances, but I feel like if I say the word mean too much, we get confused. So find the mean, find the distance each value is from the mean, and then average those distances, find the mean of the distances. This number that you get after the averaging the distances is your mean absolute deviation. So we're going to work through an example together. A says, the table shows speeds of 10 birds. Determine the mean absolute deviation of the data. Round to the nearest hundredth. Describe what the mean absolute deviation represents. So we're going to look at all of these values and say, okay, can I find the mean? Sure. We're going to add up all of our values, divide by 10 because there are 10 values, and we get a mean of 78.6. Now we need to find the distance from the mean. So we're going to subtract and find the distance every single number is from the mean. So 78.6 minus 72 is 6.6. .95 minus 78.6 is 16.4. 80 from 78.6 is 1.4. 106 minus 78.6 is 27.4. 78.6 minus 68 is 10.6. So we've done 5 of the distances with 5 more. So 78.6 minus 65 is 13.6. 78.6 minus 70 is 8.6. We have another 65, which is 13.6. 88 is 9.4. And 77 is 1.6. So this was step 2. We found the distance each value is from the mean. Now that we found each distance from the mean by subtracting, we're going to find the average of these values. So if we add all of them up, divide by 10, we get a mean absolute deviation of 10.92. So what does 10.92 mean? 10.92 tells us the average distance each data value is from the mean is 10.2. So they're all on average about 10.92 away from the average of the group of data. So we're going to look at a second example. The table shows the running time in minutes for two kinds of movies. Determine the mean absolute deviation for each set of data, round to the nearest hundredth. Then write a few sentences comparing their variation. Okay, so we have two separate sets of data here. I'm going to go ahead and just draw a line and cut that in half so that we only deal with comedy first and then drama second. We have 5 values. We're going to add our 5 values, divide by 5, and we calculate a mean of 94.2. So now we are going to subtract to find all of the distances from the mean. 90 is 4.2 away from the mean. 95 is 0.8 away from the mean. 88 is 6.2 away from the mean. 100 is 5.8 away from the mean. And 98 is 3.8 away from the mean. So these numbers here were the distance from the mean. So now we're going to go ahead and average those distances. So we're going to add those 5 numbers up, divide by 5, and we get a mean absolute deviation of 4.16. So now we'll look at drama. Our mean for drama, we're going to add up those 5 values, divide by 5, and get a mean of 132.8. Now we're going to calculate the distance each value is from the mean. So we have 17.8. 120 is 12.8 away. 150 is 17.2 away. 135 is 2.2 away. And 144 is 11.2 away. So once again, these are our distances from the mean. We're going to take these 5 values, add them up, divide by 5, and we get a mean absolute deviation of 12.24. It asks us to write a few sentences comparing the variation between comedies and drama. I'm going to make 2 separate statements. So my first statement that I notice is the MAD, the mean absolute deviation for comedy running times, is less than the mean absolute deviation of the running times for drama. So once again, the mean absolute deviation for comedy running times is less than the mean absolute deviation for the running times of drama. Another thing that I noticed is that the running times for comedies are closer together, because the average distance from the average time is 4.16 minutes versus the average distance away from the average time for a drama is 12.24. So there's a much wider range here.